Hello, I'm Dara O'Briain and this is my very own School of Hard Sums. We're going to spend the next hour or so throwing around a few digits in an attempt to prove that when it comes to problem solving, maths should be your go-to location. This show is a classic battle of brain versus brawn. I'd attempt to solve everyday issues with plain old adding up and taking away, while my guests will use muscle, overconfidence and lucky rabbit's feet. It's not rocket science, although it might be. I don't know, I haven't seen the questions yet. We'll be tackling 3 real-life problems set by our very own Oxford professor, Marcus de Soto. We have a bunch of math students present to give me a run for my money, plus we'll be trying to answer questions from some School of Hard Sums fans. Before all of that, let's meet our interns for this time. It's Lee Mack and Miles Jock. Hello, gentlemen, how are you?
I'm very well, yes.
Miles has been here before, you have not. This is your first time here.
It is my first time, yeah, and I'm genuinely excited because I'm very good at maths.
Are you?
Brilliant, yeah.
Has it impacted on your life in any way?
Absolutely. I know about 3 for 2.
But you've done various jobs that at least have numbers floating around.
Yeah, there's, well, I was a bingo caller, but I'm not sure how much maths is in bingo calling. But, yeah, I worked in a bingo.
But don't you have funny names for numbers and things?
Well, you used to, but they genuinely had to stop them. You know, you can't say... Well, you can't say 2 fat ladies, 88. They don't particularly like that anymore because that's fattest.
So
and,
right.
Kelly's eye is offensive to people called Kelly with one eye. Specific target sort of insult. Key of the door doesn't work anymore. There's all plastic cards now, isn't it?
It's all swiped.
It just all feels very old-fashioned, yeah.
Key of the door 1.
Yeah.
But presumably there's some element. I mean, it's a game, so there's the...
the maths of how many possibility of bingo cards there are.
There's 15 numbers on a card.
1 to 15, then...
Yeah, so it can be any 15 from 90.
Yeah, it's something like a number with 27 digits in it is the number of possible bingo cards you could make.
What is bingo?
So...
It's basically, it's how poor people buy spam.
Oh, that's good.
I say buy, they win it, yeah.
Right. Oh, it sounds fun.
It does, it's very popular. You should check it out. Miles, to loftier themes, you studied divinity, I believe. Was there much maths in the Bible?
Well, there's sort of numbers that recur over and over again, I suppose. We have, like, the Old Testament. I think there's this idea, maybe you'll put me right on this. In fact, you could probably put me right on most things that I'm meant to have studied at degree level. But, like, I think in the Old Testament, the sort of 7 was the sort of considered the Hebrew number of perfection, whereas in the New Testament, 6 is the new number of perfection.
You think if 6 was such a good number in the Bible, you think 3 6s would be brilliant, but it's the opposite, isn't it?
Exactly that. Exactly that.
But there's also... there's a calculation of pi. In the Old Testament as well, because some of the dimensions for the arc involve... There's one to try and create a circle, but if you work out what the calculation is, pi comes out at 3, which means the circles in the Bible were hexagons.
I'm not sure if any of this is any help in determining the theme.
No connection with this week's theme.
OK.
This week's theme is yo-ho-ho and a bottle of sums. So it's maths for pirates. So the first question we got to warm your pirate brain cells up is about cannonballs. So actually lots of injuries at sea are caused not by scurvy or being attacked by other pirates, but cannonballs loose on the boat, sort of knocking pirates over. So the task I've got for you is to stack cannonballs safely, but also the challenge is to try and make them as high as possible. So I've got some cannonballs waiting for you over on our table.
Fantastic. Come on, come over here.
So you've got this tray here, which you can fill with cannonballs, but the challenge is to use your cannonballs to try and make the tower as high as possible. OK, so there are 124 cannonballs.
Why do you want it as high as possible?
Because then
not as stable as possible.
The pirates will notice it more if it's high. If it's low, they'll start tripping over it. So let me just give you a few dimensions.
Oh, sorry.
So you might want to do some maths, Dara. You know, look at you. You're doing it kind of brawn style already.
Yeah, well...
We'll just chip them in.
Yeah.
OK, so the tray you've got is 80 by 80 centimetres, and the diameter of the cannonballs is 10.
Can I just say, I think this is pretty efficient, the system you've got in the baskets. Why don't we leave it like that? Because they're safe. There's nothing going on with that,
baskets,
is there?
that's right.
Yeah. I put one basket on top of the other
We should
basket.
get high now, because we've just nicked one of
Dara's. Yeah, you've just nicked one of Dara's.
That's four of them.
All must be fair in love and war.
This takes me back to the bingo days. I was a lot smaller then.
If anyone at IKEA has died, this is what they do with the ball crest. It's a very sombre atmosphere. It's a mark of respect.
It's only black balls in the ball crash.
Why don't we tightly pack the 8x8 before we do anything?
I actually assumed that we were doing that already without talking about it.
See, Dara's gone for the kind of conventional.
I'm trying to see past the conventional just because of the fact that this thing is presumably on a ship. So therefore it's going to keep rolling around the place.
Yeah, so you need it stable. You've got a nice stable base there.
Yeah.
Maybe this is a vital stage, actually.
I think maybe a star shape rather than a square shape.
A star shape?
Yeah. Like that.
This is absolutely mind-blowing.
Shaped like a star. Shaped like Freddy's star.
Good, yeah, good reference, good reference.
So, Lee, you mentioned a star.
Yes.
But you've got a lot of squares here forced by your base.
I say star, I meant sort of pyramid.
Yeah, pyramids. But you can do a different pyramid, which
A three-sided pyramid.
An upside-down pyramid.
Can you do a triangular pyramid?
Well, I don't know. I'm just...
I'm wondering how you would do that.
Yeah, but your base is forcing you into a particular sort of pyramid. So if anyone wants to try an alternative pyramid... Oh, no. Oh, look, Dara's...
Oh, yes, make the triangle at the bottom first. And it'll be a naturally three-sided pyramid, wouldn't it?
This is pretty good. You've got a 5 by 5 square on the bottom. So
some of these will do holding jobs, right?
Can we use these corner ones to make another height?
Well, look,
but I think we should...
Let's just stack up.
Like that.
They're all furiously working.
I'm not sure I trust them a lot because they are sat at tables that are too small for them, so they actually look like kids that have been put back every year.
Basically, you've constructed the same pyramids, which are square-based pyramids with 5 long... And the maximum you can get is the height of 1, 2, 3, 4, 5, 6. Have any of the students got something which is alternative to the two arrangements here?
You need to change your type of pyramid. You need to do a triangular-based one instead of a square-based one.
Triangular-based one?
Because you get more height and less base.
Right, it's happening. It's happening.
Izzy is absolutely right, because if you think about how a greengrocer packs oranges, they don't do them in squares, they do them in hexagons or triangles. So if you make triangles here rather than...
Older just stick them in orange bags. I don't know what you're talking about.
That's the base.
Ah, yes, see, that's good.
So that's...
I'm still unsure that unless... You've got to pack the bottom, haven't you?
Okay, I'm going to have to call time on this problem.
Really?
Yes, I'm afraid so. Because it was a tie, you both got the same height. But actually, Dara, if you do continue your pyramid there and make a triangular-based pyramid, you'll find that you can actually get higher than the square-based one.
Solid.
For 2 reasons, actually. Because, first of all, the height at which the balls are sitting above the balls below is actually taller than in the square pyramid. And you need fewer balls to make your pyramid. In fact, you see that in Guatemala. The pyramids are much more sort of similar to this shape because they want to get above the canopy. So this is actually an ancient problem that was set by Sir Walter Raleigh, who wanted to know the most efficient way to pack cannonballs. And in fact, it was Kepler, German mathematician. Kepler's problem was, is this the most efficient way to stack cannonballs? And in fact, we have a manuscript that Kepler wrote, and you can see some of his stacking of cannonballs in this text. And the maths of cannonballs turned out to be really difficult because it was only about a decade ago that finally it was proved that this is the most efficient.
OK, well, we've blown away. Right, so therefore, we'll leave that with people, that there is a way of doing with how many? With 124. 124,
yeah.
To get one higher.
You can get one higher than that, but already that's higher than what you did before.
That we'd previously done. The first move was key in this puzzle. If you start as we did by arranging 64 balls in an 8x8 grid on the bottom, you have 60 balls left, enough to build a square-based pyramid in layers of 25, 16, 9, 4 and 1 at the top. That's 6 layers high and 5 balls left over. However, there's enough space to pack the balls 8, 7, 8, 7, 8, 7, 8, 7, 8 in a tighter diamond arrangement as I did on my second attempt. This uses 68 balls and leaves 56, enough to build a triangular-based pyramid with layers of 21, 15, 10, 6, 3 and 1 at the top, 7 layers high and none left over. Using Kepler's sphere packing equation shown here, you can calculate the heights of the towers, including the base layer, as 45.36 centimetres for the square and 58.99 centimetres for the triangle. OK, join us after the break when a School of Hard Sums viewer seeking an answer to an everyday problem will be putting us all on the spot. We'll see you then. So, bye-bye. Welcome back to School of Hard Sums, the show that pits my grey matter against the muscle of two popular but mathematically challenged comedians. Is it harsh? Possibly. Later on, we'll have more devilish math questions from Oxford Professor Marcus Sotoy, but first we hear from fans of the show who think that our unique combination of brain and brawn might be able to provide them with answers for their everyday dilemmas and niggling problems. So let's have the first question.
Hello, I'm Janet Street Porter. Now, I've been married 4 times. 2 husbands each lasted 7 years. And 2 husbands didn't even last a year. So if I was to get married again, what's the mathematical probability of it actually lasting?
What is it about Janet Street Porter and husbands and teeth where she's not, like, happy with the amount we've got? Do you know what I mean? She always has to go a bit too much, doesn't she? Do you know what I mean? 4's a lot of husbands, don't you think?
It's certainly more than I've had.
Yeah.
There is an issue that how we define it lasting. Janet's not in the first flush of her youth anyway, so really, either 1 or 7 years could be enough anyway.
No, but that is lasting. It's till death us do part. So that is a successfully completed marriage.
Whoever carries Janet out of that church and puts her in the ground is the winner in that situation.
Is it like pass the parcel? When the music stops, whoever's holding it.
Yeah, whoever's sitting in the chair marked husband of the deceased is the winner in that situation. Yeah. Can we send Janet home with a positive message?
But actually, there's research done by a professor in Oxford, Professor Murray, who's used a mathematical analysis of 15 minutes interview with a couple, and he asks them various different things which he scores according to the tension that it raises. And with 94% accuracy, he can predict those marriages which will actually last.
He doesn't sound like a dream dinner party guest, does he? He sounds like someone that could have caused an awful lot of quite stressful evenings.
Yeah.
Oh, how perfect it would be, though, at the end, if you say, we're not going to tell you what this guy does, but at the end, then, and then we explain it, and he just goes around the table and goes, yes, yes, no, yes, no, yes, yes. Yeah. Good night. That'll be the way to go. OK, we have a second question.
Hi, I'm Angela from Bedfordshire, and I've come to watch the England game. I want to start a Mexican wave. How many people do I need to help me?
Well, preferably all of them, because otherwise you look like a bit of a twonk. And there's always one sector of the ground that doesn't take part anyway. You know, usually the corporate box end, and then get booed by everyone else.
I don't get involved.
I hate them. I hate them.
Do you know when we moved to the Emirates? Because at Highbury...
We're both Arsenal fans.
We're both Arsenal fans.
I didn't think you were living in a gay relationship and you bought a new house in the Emirates.
Yeah, we moved just outside Doha. It's lovely. It's just on the beach,
Highbury, you could never do a Mexican wave because it was 4 sides of a rectangle. But when we moved to the Emirates Stadium... suddenly you've got a second, and they started doing Mexican waves.
Can't a rectangle work in the same way as the circumstances?
Because it kind of stops when you hit that side. The other side don't...
And there's just enough of a pause for the people in the next stand to go...
Mathematically, we call it a discontinuity, because it isn't a smooth curve.
What's the number of people that have to do it that it carries on?
To start it off, I'd imagine the number would probably be surprisingly small. I'm guessing that if she could get... something like, well, I don't know, 30 people around, or 50 people, 10
Well, you're absolutely right, because 30 is about the right number. A Hungarian university looked at all the Mexican waves that were being done, and they found that the critical number was about 25 to 35. And if 25 or 35 people got up, then that would just have this cascade kind of emergent.
What about if 25 do it and 26 stops? I'm still not confident it's going to carry on.
I think 25 would be enough of the people around them will therefore do it, and it will pick up.
It will then be noticed.
Oh, like a sort of chain letter, sort of growing.
Exactly. This is great. We actually have a solution to that one. Do you have a question 2 for us?
I do have a question.
We can work out,
back to the pirate theme. So, yes, lots of arithmetic or something like that.
That's not going to carry on throughout the show, is it?
No. All right. You get 1 free pass.
Oh, go on. No.
Can we please go back to the question?
Well, you're going for a job interview at the International Bank of Pirates. Now, pirates are a shifty bunch, and so I'm going to give you a little test to see whether you can work out of 10 bags of coins, which bag contains fake coins which weigh a little less than the other coins. But I'm only going to give you 1 chance to weigh a selection of the coins. So let me take
questions for me, but let's walk over and really see the setup.
Better to see them.
Yeah.
The coins that are real weigh 100 grams. So 9 of these bags have the real coins in, and they have 10 coins. But there's 1 of these which has fake coins, and each coin in there only weighs 10 grams. So here's the challenge. Yeah, if you could weigh them all one at a time, you'd be able to work out which one weighs less. But I'm only giving you one chance to weigh on my weighing machine. In fact, we're going to weigh the bags with the coins in. So you've got to take coins out of the bags.
But do we physically take the coins out, or do you?
I'm going to do that.
Otherwise, I might feel it's a bit light.
Hey, that's a little bit light. It's this one.
So we have 9 bags of real coins and 1 bag of fakes. There are 10 coins per bag. Real coins each weigh 100 grams, and fake coins each weigh 10 grams. You can ask Marcus to remove coins from any of the bags, but can only conduct one weighing. How on earth do you find the fakes? Oh, and because these are interview conditions, we're only interested in the coins, and you can assume that the weight of the bags won't affect the outcome.
So I could take 1 from here, 3 from here, 2 from here?
Yeah, and then can you tell by your choice which bag contains the fake coins?
I know this. This is one of the. It's a great classic problem, and while I would love to stand here and pretend to rederive the solution to it, I don't know if I got this right or I simply read it and says, I know.
You'd have to act, wouldn't you? You'd have to act.
And I'm not about that. Yes. I can't do that.
It's such a classic, actually, that I was on a train back from Reading to London, and this guy just set me this problem on the train. I think I've obviously been chatting to somebody and he's heard a bit of maths, and he said, oh, I got a really good challenge for you. So,
why can't I have train journeys like that? I just have screaming kids and people throwing cider cans at me head.
The time of day you travel.
Yeah. And also, I'm with my family. So, now, if we took half of every bag, so 5, 5, 5, 5, 5, all the way round.
It's the same problem, but
50 coins.
I think we only need one from each bag, because they're all... I think this problem ought to be the same regardless if there's 1 coin or 10 coins.
Yes,
well, that's always a good proportion.
Yeah. 1 coin or 5 coins or 9 coins, it's the same number of coins in the bag, yes. It is the same problem.
But we are to see... But you just do one...
I'm going to do one weighing, and just to keep things nice and smooth, I'm going to weigh the bags. So you're going to tell me how many coins you want to take out that you're not going to weigh, and then we're going to put whatever bags you want on.
So let's start with the basics. If we weigh all of them as they are now and put them on there, they are going to total 9.1 kilos.
Yeah.
Is that right?
Exactly.
That's the one I've got. I'm out.
One way of doing this would be choosing a bag at random and go, right, weigh bag number 1, and if it comes up as so-and-so, then it is...
Yeah, that's the one.
OK,
that's
the one.
A 1 in 10 chance.
Yeah.
And is this for us to work out?
See which one
can I do some maths on here?
I'd be happy for you, Lee, to do some maths on there. It's usually Dara who scribbles on there.
Oh, I see, sorry.
Listen, let me move this over here so we can have a look at your excellent work.
May I ask a question?
Yes, of course.
I'm assuming we can take disproportionate amount of coins out of each bag. We'd have to take the same amount of coins out.
Not at all, and that seems...
In fact, that's quite a relevant thing to do,
I think it is
an interesting thing to do.
So a different amount of coins per bag. Do you think...
You could either be going up by 1, so it was 1 from 1 bag, 2 from 2 bags, and we could work out the maths in advance.
So obviously this is to do with taking out, weighing and working out what's left.
It may take them slightly longer to solve this one than we thought, so join us after the break to see how they get on. And later, we'll be tackling the show's meatiest maths problem, and we'll find out exactly why Lee and Maz have been doing this.
So you're going to be the pirate.
I will be the pirate. I've got quite a big head. It's very big at the back. I know what I'm doing.
Welcome back to Dara O'Briain's School of Hard Sums, the programme which pits me using brain against fellow comics using brawn. In this case, Lee, Mac and Maz Jupp. So before the break, Lee and Maz were trying to work out which bag in a pile of 10 bags is filled with fake coins, which are lighter than real ones. They aren't allowed to touch the bags, but they can ask Marcus to take coins out, and they're allowed just one weigh on the scales. How's it gone?
Well, we had a game of noughts and crosses. I won that.
OK.
I don't know why I'm saying this. It's not based on maths other than a gut reaction. Is it 1 from one bag, 2 from the other, 3 from the other, 4 from the other, 5, and can go till you get up to 10?
Should we try that?
To go from 1 to 10.
But then what's the answer that you need to find? We need to be able to use the answer that comes up to tell us...
So let's work it out.
What do you think you'll get? If you take
what's 1, 2, 3, 4, 5, 6, 7... What does that add up to? What's that? How many bags are there? 10?
Well, yeah.
OK, well, let's...
19, 27, 34, 45, 49, 52, 54?
OK, yeah, we can do this from here. Yeah.
19 and 15, 30,
No, it should be 55.
49, 52, 53.
Shall I tell you a quick way to do that? No, look. If you pair them up, what do they all add up to?
11.
Yeah, and how many have you got?
You've got 10.
5 pairs. 5 times 11. 5 times 11 is 55. Are they mocking me?
Yeah, they are.
Yeah, they are.
I feel like I'm on a very brainy version of blankety blank. Right.
If we know which number of coins are coming from which bag, then we can deduct the correct number to get...
That's it.
Why is that?
Because we know how much disproportion is, because we know that... We're allowed to know, aren't we, that 4 came out of 5.
Yeah, exactly. For example, if I took 9 from bag number 1, so I've left 1 coin in here.
Yeah.
If this is fake, how much will this weigh?
That will weigh 10 grams.
Yeah, and if it's not fake, it will weigh...
100 grams.
Well, exactly. So we know how much that one... So if I took 9 out of that one, and it suddenly comes up with...
We've solved it. I think we've done this.
Yeah.
So how many do you want to take out of bag 2?
Well, let's give it simple.
Take out 8
Take out 8 out of bag 2?
And so on.
OK.
So what answer
There is a bit of clapping going on over from the students. I think they...
So if we...
I'm going to try and do a big sum.
Okay.
Find out the weight of...
So there's 9 from bag 1, 8 from bag 2.
So let's say, hypothetically, it's 6 is the fake bag.
Okay, hypothetically
is that what's
6.
left or what we took out?
That's now what's left in the bag.
Right, so we took 4... If it's correct, we took 400 grams out, or we took 40 grams out, depending on if it's correct or not correct. Do we agree with that?
Yeah.
We took out 4
what about
coins weighing
students?
400.
Have they got any?
They've all got it. Yes, of course, that's exactly it. Yes. I really, at this point, I just give prizes for which is the most beautifully drawn one. You've actually drawn pictures of the bags. Flip them over here. There we go. Lovely. Actual pictures of the bags. How sweet is that? They'll get more difficult. Don't look at me like that. The next one will be more difficult. They're feeling very cocky in there, as I said.
Yeah. They were all correct weight, and we weighed them. Then it should weigh 5,500.
Yeah.
What we've just weighed out. What we've just taken out should weigh 5,500. We know it's not going to, because one bag contains less. It contains the fake
But
one.
maybe it's just
so
about 55 minus
so the question
10,
is
55 minus 9.
How less than 5,500
exactly.
tells us which bag it's in.
So, for example, if bag 6 was the one with the fake in...
it would be 5,440, wouldn't it?
Yeah.
So if it weighs 5,440, we know it's 6.
No, it wouldn't weigh
It's
that.
5,500 minus...
No, it wouldn't weigh that.
So you're being, Dara, very, very negative. We're trying to do this, which I realise is a maths term. We're trying to do this at our own pace.
I'm not sure I want this job.
But actually, I've left in bag 6, I've left 6 coins in bag 6, 5 coins in bag 5, because I think the strategy you told me was to leave...
So you've left 1 coin in bag 1?
I've left 1 coin in bag 1. So there are 6
But you've got to reverse it.
It's just there are 6 coins in bag 6. So it'll be 60 grams if it's fake.
All that is 5,500 minus 540, isn't it? Am I going mad? Isn't it 4,960?
Okay.
So if it weighed 4,960, it's bag number 6.
Okay,
so
shall we have a go?
The last 2 digits tells us which bag.
There we go. There we go. Fabulous. That was a beautiful moment. None of this matters. None of the first digits matter at all. It is
the last 2 digits.
The last 2 digits.
So do you want to stick them on... actually, you can help me stick them on the weighing machine. Let's see. Oh, there you go.
There we go.
Depends if we're rounding up or down there.
Yeah, we round down. That's an acceptable margin of error to get the job. So, absolutely. Lee and Miles, you win that round.
Oh, entirely, absolutely.
Because Dara, you knew it already.
That's cheating. That is cheating. Previous knowledge is cheating in this show.
I tell you another way in which you were wrong. You created an atmosphere in which it was difficult for us to believe in ourselves enough. Very, very
I think when you
stifling.
rolled back the tape, you'll find I never raised my voice.
You did have to raise your voice. You got inside here in my brain with a whisper.
But you got it.
You didn't hear this at home, but he kept whispering, "You're useless." It was useful.
I almost saw that kind of aha moment when Lee went, it's the tens which is going to tell you. So you got the job, guys.
The key to this puzzle is realising that on our digital pirate scales, the total number of real 100-gram coins weighed can only affect the 100th column or above. Therefore, the readout on the tens column can only be affected by the fakes. So leaving 1 coin in bag 1, 2 in bag 2, 3 in bag 3 and so on means that when you put the bags on the scales, the tens column will display the number of the bag containing the fake coins, which in our case was bag 6. Well, it's a lovely solution, even though an ugly tone seemed to creep into the whole proceedings. Tell me, though, about the big problem that we have this week.
This is about pirate pursuit. So you're in a pirate ship and you're chasing a merchant ship, and suddenly a fog descends. And the merchant ship decides just to go in a straight line at a constant speed towards the port, but you don't know which direction the merchant ship is going in. So the challenge is to come up with some path for your pirate ship which will guarantee you to intercept that merchant ship even though you're in this deep fog.
Oh, my. All right. Do you have any more information than that?
Yeah, there's a little bit of a difference in speed. In fact, I mean, I'll let you go 5 times faster, although actually, you know, it's quite generous.
You know where the port is? Do we know where the port is?
No, you don't know where the port is. Exactly.
Oh, my Lord.
Yeah, it's quite a challenging problem.
So a boat you're chasing suddenly disappears in fog. You know 2 things. 1, that the boat you're chasing has sailed off in a straight line, and 2, that your boat travels 5 times faster than the boat you're chasing. What kind of path should you follow so that you can catch the boat no matter what direction it has sailed off in? Okay, that's interesting. Yes, I have no idea how to start with this. You've been out and tried to do this, haven't you?
We have. We did it. We had a lovely, I would say, romantic day. Would that be?
Yeah.
Of the day?
And relaxing.
Okay, let's have a look at how your day went.
Well, I think it's safe to say that this is something to do with pirates. Task. Task.
Task.
For the purposes of illustrating this, let's imagine that I am a rich merchant.
Oh, here we go. Typecasting already. OK,
I think
I'll play the sexy pirate. You said sexy, didn't you?
I said, yeah, and you're chasing me, as you would. Why make money honestly when you can just steal? OK, so you're going to be the pirate.
I will be the pirate, but you will still... Am I right in saying you will still help me with the puzzle? I'm not... You're not just going to go and then I'm just going to... Yeah, we're still a team, right?
Of all the places that I'm going to leave you stranded, I'm not going to leave you stranded as somewhere with transport links as good as this.
I was going to say,
when I desert you, I will really desert you. You stay there. I will give you all the things that I think you need, Lee. Probably that. Probably need that.
Yeah,
maybe that.
You're like a very middle-class Father Christmas.
A couple of bottles.
I think you'll probably need this. Oh, that's good. Everyone needs a spade.
I'm sorry if I'm sorry if you feel I'm disappointing you, Lee, in any way. Now look.
I've got quite a big head. It's very big at the back. There we go. I've got this weird spade as an arm and these bad... I do look like I've become really badly dressed as a fancy dress party as Abu Hamza.
We need to find boats in which we can replicate this situation.
Should I follow you?
If you wouldn't mind.
Yeah. Don't worry, I can cope. It's fine. Miles? Oh. Wow.
That is extraordinary.
How do they get the masts? I mean, it's amazing. Don't worry, I know what I'm doing. I know what I'm doing. I know what I'm doing. Everything will be fine. I know what I'm doing. Miles, do you remember Rent-A-Ghost?
No.
It was a show in the 1970s when I was an old man.
Oh, tiring.
And what we have to do is we jump, and when we land, we're wearing the clothes, and that's what they used to do in Rent-A-Ghost. So let's do that now, and then we'll magically appear dressed as pirates or merchant bankers. Are you ready?
Yeah.
Go for it. Well, it didn't work, but it used to work on Rent-A-Ghost. I know, you need to do an edit, that's what you do. Let's try it again. Good, eh?
That's not at all bad.
Right, this way to the boat, sir.
I'm sorry, is that actually a thing, that place with the... where you
That's
can...
a day out.
That's it.
You're probably thinking, is that it? Oh, no, you can do pirate crazy golf as well.
It looks like your mother just left you in that and put a lot of 10 pences in and then walked off into the shop and then just left you slowly whirling around.
Round and round.
OK, Grant. I'm going to leave you guys to chat about this while I try to get some sort of more abstract spin on this. Let me go over and try to work this question out.
Right. We get a chance to look at one of my favourite mathematical objects, which is this thing here called a gumbots.
Right.
So you can have a play around with it and see what you think's significant about it.
It's got no flat sides.
Well, I suppose it's the amount of sides is relevant.
I think despite not having any flat sides, it will always land exactly the same way up.
Yeah. So have a roll.
It has to return to the same...
Is that not just because it's heavier at the bottom?
No, this is the interesting thing, because this is uniform density all the way through. If you had a sort of two-dimensional disc or something, you tried to cut out a shape, in fact, there are always 4 points of stability. If you think about an ellipse or something, then an ellipse will either settle on the sort of flatter side, and there'll be 2 sides you can do, or it'll be unstable on the sort of pointier side. And it was thought that maybe all 3-dimensional shapes also have at least 4 points of stability. And this one only has 2. It has a very unstable point because it
theoretically, you could rest it there and it would stay upright.
If you've got it
just right. But usually, most shapes have at least two places where it will sort of try and rest.
That's always going to land on that exact one point.
But however you try and do that, because that looks like it's... Ooh, no, but then...
Oh,
it's so well engineered, that thing, that that even a piece of paper will stop it rocking over.
Oh, I see, but it's not like there's just bits taken out. There's an extra dimension to it.
But it's actually created by a Hungarian couple of engineers. And in fact, one of them on his honeymoon spent all of his time on the beach picking up pebbles, trying to see whether there are any shapes. And he never found. He tested about 2,000 pebbles. And it took sort of mathematical analysis to actually come up with this shape, which is kind of slightly weird shape, but it will always come back to this one point.
But is there a practical use?
Yeah, there is practical use, actually, in nature. So what animal do you think might use this shape in a practical way?
Oh, a tortoise. Oh, a tortoise, yes.
Exactly. It's actually the Indian star tortoise.
To get back up again?
Yeah, so if that gets knocked over, you know, it could do a bit of aerobatics, but actually the best thing is to have a shell which has this property which is called monostatic, that it rolls over.
And yet, they're not known for running, are they?
OK, we're going to take a break now. Join us now to see how I get on with my calculations and to find out why Lee and Miles were doing this.
Miles! Hello, Lee. All right, Lee, you're not going to get me. Oh, you're back? I'm back. Right, you've not caught me.
So that failed, yeah?
Oh, I've grounded.
Welcome back to Dara O'Briain's School of Hard Sums, where I'm partway through working out, well, I'm not really anywhere close to it, it's just rough work at the moment. It's a very taxing, piratical problem set for us by Marcus de Sautoy. So a boat you're chasing suddenly disappears in fog. Your boat travels 5 times faster than the boat you're chasing. If the boat you're chasing is sailed up in a straight line, what kind of path should you follow so that you can catch the boat no matter what direction it is sailed off in?
So, Dara, I have got a little bit of a hint for you, but I need to prepare myself for this hint, actually.
Okay.
So let me just put this up here. Hopefully my hint is going to arrive onto my arm.
You're joking me?
No, I'm not.
Really?
Yeah. Oops, there it wants to go. Oh, that's right.
Nice breeze, isn't it?
Right, there we go.
Could I join you?
Yeah, come and have a look at this.
Sorry, I'll go back to the calculations in a second.
Yeah.
Oh, my God, he's fabulous. What is he?
Right.
It's a novelty wristwatch.
So this is a hawk, and actually, of course, a hawk does a lot of pursuing.
Yes.
And
presumably, when she hunts,
yeah,
the things she hunts curve away from her. But
no, they bomb away as quickly as possible.
Oh, they go straight. They go in a straight line.
They go in a straight line. But
she doesn't know where they are. She's not doing this in fog of war. She doesn't know where they are.
No, exactly. She actually sees the prey. But there's one thing about her eyes, because the optimal place to look out is at a kind of 40-degree angle. But if it cocks its head, it slows itself down. So it constantly wants to keep the prey at a 40-degree angle to its flight. So which it results in a rather beautiful path that the hawk makes. It doesn't just go in a straight line. In order to be able to keep the prey in its sights, it actually does a beautiful mathematical curve, which is the hint for your problem, because you might be doing a similar sort of curve to the one this one's doing. I think it wants to go.
Yes, yes.
And
wow, that's very beautiful.
Yeah.
A hawk's vision is best 40 degrees to the side of the direction it's flying in, which means it cannot fly directly at its prey, but must curve around to keep the prey in this sweet spot. Knowing Marcus, this curved path the hawk follows must be similar to the one I'm looking for.
Right, I think we can have a look at what Dara's been doing. I think the interesting thing is actually down here. If you look, he's got some examples of directions that the merchant ship could have gone off in. Suppose the merchant ship was going there, then I could just go in a straight line. But if it isn't there, what have I got to do next? Well, I've got to head in some way, and if it's there, I'll meet there. And then if it isn't there, I'd have to go further round. And so actually, you can see, just by an approximation, the sort of spiral that would... you've got this kind of spiral effect, so you suppose it was going off here, so it got much further, so you'd have to go at that point. So it's a good beginning, but there's still the equation missing there. Do you want to come and have a look and see what the students are doing?
Yeah,
Let's see whether...
Yeah, let's go and see what the lead singer of Roxette's doing. Yeah, well done, sir. I like the idea. I feel like a teacher and it's exam time. 2 more minutes, please.
That's it.
Let's have a look at the equations then.
You know where your ship disappeared, so you have to travel towards where you saw it go, and then by the time you've got to there, it will have travelled a distance of d/5 in an unspecified direction. So you don't know. So you have to spiral around that point, like take a full circle. So, yeah. That's pretty much what we've got to. It has to be a spiral.
I mean, there are lots of different sort of spirals that you can define in mathematics. You probably did coordinates to like x and y coordinates. So you go x along this way, y up there.
Yeah.
But in mathematics, we have this thing called polar coordinates, which says just go at a certain angle and then a distance out at that angle. So they're called r and theta coordinates. And they're actually much better coordinates for writing down the equation for the spiral that they're trying to make. But if you're at an angle of theta to, say, the horizontal axis, how far could you be out, which will give you a spiral? So you could be e to the theta far away.
Did you say e to the theta?
I said e to the theta.
You sound like a really posh rapper. I like that.
Kind of math rapping.
How are you getting on?
Hello. Yeah, I've hit a wall of... OK, what I've done is, we started to say here, right? This is where you went. Rode the boat to where it used to be, to the point where we're at the same radius as its circle. So this is where you start your spiral.
Yeah.
So you start your spiral here, and so that's your position is that.
Nothing.
That's theta or cos theta. And or is equal, the radius that is out is just the velocity by time, which is the radius that this thing is moving, its circle is moving out, plus a distance here. But then the velocity, therefore, can be written as this, minus or sine theta or cos theta. The absolute value of that is 5v.
Yeah, it is kind of relevant to the definition of the curve.
It is, OK, grand, but that doesn't reduce out in any interesting way.
Yeah, yeah.
It doesn't, unfortunately.
What would your... I think I'm going to call time on this, and I'm going to get you to go for... You've gone for a spiral, but what sort of spiral? Because there are many different sort of spirals in
I don't even know what you mean by what sort of spiral, given that I clearly...
What he means is the distance between the spirals even, or does it spiral bigger and bigger? Or to put it in the way that you said to us before, no, you don't need any of this, you don't need any of this, no, you don't need any of this, no.
Don't bask in your pleasure at this. OK. At least until we see this. Let's see how you do.
We nailed it in 2 minutes. We got there at 5 to 12, we're in Nando's at midday.
OK, very good.
That's all you need to know.
Let's see the total extent of your work then.
There must be a route that you can take that, irrespective of where the port is, irrespective of how far away from you I am when it starts, you will encounter me sometime.
I've got a driver because we can't create mist. We're going to blindfold me. You haven't met the wife, have you? Janice? Miles Janice.
I have heard so much about you.
She's got a deep voice, but she's a lovely cook. I'm coming for you, sailor. My first plan is to do a massive circle. Fog descending, right round the edge.
This is already going spectacularly wrong.
Is he close? Give me a clue. So the circle didn't work.
We should try something that is, circular in some way.
Yeah.
But it's something that has a sort of, if it was the figure of 8.
Right, let's do a figure of 8, a massive figure of 8.
And fog descending now.
So if we get him on the way back round again, the problem with that is we'd have to meet him right at the point where the 2 circles meet.
Yeah. All right, Lee, you're not going to get me.
Oh, you're back?
I'm back.
Right, OK, that failed. What about a circle, an ever-decreasing circle?
OK, what I think is you start small and get bigger.
I'm actually going to keep the blindfold off this time.
Fog descends.
Now, I would say the chances of ever catching him on spirals is looking slimmer if we go round. But, I'm willing to go for it.
Right, you've not caught me.
So that failed, yeah?
Oh, I've grounded.
Right.
And fog descends.
We do look like Brian May and Anita Dobson on a nice day out at the canal. We're going to do spirals. Which way's the spirals going? Sorry, I'm a bit confused. These aren't spirals now. Where are you going?
He's arguing with his staff now. That is...
No, you've done a figure of 8. We wanted spirals.
Total chaos. You're across the front of me. You're going to hit me,
you.
and...
Yeah. and would get you.
Bang.
Right.
Well, that worked. That seemed to work.
Yes. I think the gap of the spiral increasing and what percentage that is each time is key.
I think it's got to be like
to the experiment. Wouldn't you agree, Anita?
Like the way you look at a snail shell or perhaps a Cumberland sausage. Fog descending now.
Right.
So
Start
maybe you
doing
try
the
going
old,
that way.
Cumberland sausage manoeuvre, please.
Pretty sure we've got this now. Miles! Hello, Lee.
No, I'm saying, just to be a sailor. Miles to go.
Oh, well, hang on a minute.
Well, I think
He's
we want to
getting
get
worryingly
past him,
close here.
Oh, hello. There you go. We've got the bounty. Yeah. We've got what we came after.
I'm actually going to have to defend myself. Oi!
Oh, come on.
Hands off me candelabra!
Oh, come on. That's all I've come for, you know that. So, well, I think what we've proved is, A, it's better to be Dara in a warm studio, and B, that if you travel round in a Cumberland sausage shape when chasing a man in the fog with a golden candelabra, you'll end up with a pearl necklace. And I think that is probably all you need to know about maths, isn't it?
Yes, well done. Because we're all agreed it's some sort of spiral.
Yes.
Because the radius is increasing at a rate according to t, it's an expanding spiral of some description. But
I think this has got, you've got to write down what sort of spiral. I think you came up with a spiral which you can write down on your card, and a spiral from you, if it's an equation or a sort of spiral, or if you're just going to write a spirally spiral.
Spirally spiral, yes, sorry.
And then I will judge accordingly.
You know, in what terms does one describe a spiral?
Exactly, mathematical terms.
I don't have an equation for it. I don't have an equation for it.
Right. So let's have a reveal then. So your sort of answer is a
twirly spiral. Yes.
Martin Lee, what did you come up with?
I think it's called the Cumberland sausage sequence.
The Cumberland sausage spiral. Well, very interesting, because that is a sort of spiral. It's called an Archimedean spiral, actually, if you think about how you'd lay a rope. So actually, that isn't expanding fast enough to actually catch.
Oh, sorry. So my second guess is Mr. Whippy.
Mr. Whippy. No, actually, it's a logarithmic spiral. But this will guarantee that at any point the merchant ship will head off, you will actually intercept the merchant ship with this logarithmic spiral.
Okay.
So I think that round, I will actually give it to Lee and Miles, because first of all, the Cumberland sausage wasn't the right spiral. But, Lee, you did slip in that thing that you've got to have this kind of increasing rate of distance as you go around your spiral.
I don't want to say I told you so, but I did sort of say that.
Yeah, so
Can you tell me, is there actually a neat equation for this?
there is an equation. I mean, basically, the radius here is proportional to the exponential of the angle that you've gone round. So
I'll take it from here.
Yeah, okay, thank you. So there is a formula which will have e to the a theta being the distance that you need, and this a will be dependent on the relative velocities. I would have bowed down and worshipped you had you managed to get that A, because it's quite a tricky bit of mathematics.
Oh, really?
Yeah.
I was doing stuff.
But you were doing pretty well. I think if we'd given you another week,
you know,
we might have...
that is essentially that.
Yeah.
But I just had I'm just fudging over this bit. Right,
yeah, exactly.
Yeah, but your actual answer was twirly spiral, Mr. Whippy.
Yeah.
Just reminding you. It's also your grinder name.
Lovely. The shortest possible pursuit will be if you and the other boat had a head-on collision, so sail straight there first. Once you've reached this point, turn a hard right and follow a spiral whose radius increases at the same speed as the boat you are pursuing. Imagine just plotting 8 points in a compass, and you can see the spiral emerge. All your ship has to do is sail around the edge of this emerging spiral, and sooner or later you'll collide with the other ship. A spiral that increases over time in this way is an example of a logarithmic spiral, and its formula would look like this. I nearly found the equation of this growing spiral, but foolishly used XY coordinates and not the polar coordinates Marcus recommended. The path the pirate ship takes is similar to the one the hawk follows when hunting, only it flies in the other direction, spiralling in on its prey. I think at the end of this, they've definitely won. I exempted myself from one question, didn't get another question. So I think in Brain versus Brawn...
Yeah, I think they're brainier than they look, these two, actually.
Well,
So,
I'd have to be.
At the end of all that, our thanks by the burgeoning young talent, our students and our maths fan who genuinely started getting stuff out there. Well done to all of you. Thanks to our question setter, the OED of numbers, Professor Marcus de Sotoy. But thanks to our winners, the guest comedians who are now fully paid up members of the Maths Union, Lee Mack and Miles Jupp. We'll have more of these problems, fiendish as they are, another time on School of Hard Sums. Thank you very much.
Now time for your homework. Fill the boxes below with the numbers 1 to 8, such that no two consecutive numbers are adjacent to each other, either vertically, horizontally or diagonally. If you'd like to check your answer, or just cheat, go to the website joindave.co.uk.